Hi everyone, this is Shannon Williams from Rancher Labs. Thanks a lot for joining our November meetup. Looks like we're going to have a large crowd today, so thanks to all of you for registering and your interest in learning about containers and how to use them to deploy your microservices. As I said, I'm Shannon. I'm one of the founders here at Rancher. I host this meetup every month with my co-founder, Darren. Darren, you want to say hi?
Hey, what's everyone doing?
And Darren and I have been hosting these now for almost a year, I would say. So there's a pretty good record of recorded meetups. So if you like today's content and you want to get more, we have meetups up on YouTube where we've recorded our take on logging and monitoring, on using Docker Compose and sort of basics of developing your application. So there's a lot of content out there, and feel free to follow us on Twitter to get the latest, either directly following us or following at Rancher Labs, and you'll get the latest on our meetups as we host these every month. But before we get started, I just want to kind of tell you a little bit about the way we run these meetups. We've really attempted with these events to be a lot more of a meetup than a webinar, and what that means is we really don't try to make these a lot of slides and a lot of pitches, sort of telling you why you should all use Rancher and how amazing it is. We instead focus in the meetup on just real use cases, and there's a bunch of things we do to try and make that happen. Just heads up, these meetups almost never end on time. We tend to go long. There are enormous numbers of questions that pour in from the audience, and that's because we love it. We love your questions. We love the good questions, the great questions, the amazing questions. Just fire them in. If you're not familiar with GoToWebinar, our tool, on the little bar you'll see a place to type in your questions. As you type them in, Darren or I will see them when the other person is talking, and we'll pause for a minute and read them out, and we'll discuss them. We may even open up your line if you want to ask your question out loud. So feel free to type in, "Hey, I have a question I want to ask out loud," and we'll open up your line, and you can explain what you'd like to cover. There are some times where you'll ask a question where we're just about to cover that topic, so we may say, hold on a second, and we'll get there in a minute. But by and large, there are no bad questions. So fire away and don't wait. Most of this session is going to be demos. We spend the first 5 minutes or 10 minutes or so kind of setting theory and explaining kind of the concepts we're going to cover in the demo. But by and large, these are real live working demo meetups. There's no recordings. There are loads of times where we mistype and things break, and we try to do something on the fly that turns out horribly bad. So be patient. Darren and I will be breaking things, I'm sure, the entire time we're here. So, but if you want to see something, ask. We'll demo anything. If you're like, oh, why didn't you scale that up to 500 nodes? Just ask. We'll tell you if we can. So we try to do whatever you like and take this in the direction that your awesome questions drive us. So the one downside of this being an online meetup instead of a real meetup is we don't get to meet, we don't get to see you, we don't get to chat and have a beer afterwards. So please join the conversation on Twitter. If you go and use #RancherMeetup, you'll see loads of people posting their pictures. Please post your pictures. We love seeing you. We love seeing where you're at and what you're doing and how you watch the meetup. So, and you may see yourself here next month as we slap up pictures of people who are watching the meetup. So post your thoughts as well, and don't worry, by the way, if you need to leave early. We record these meetups, so we will be making a recording available in the next day or two that you can watch the whatever awesome pieces you missed. Okay, so let's get into the agenda. We have a lot to cover today. We're going to try and move quickly. The first things is going to be just an overview of microservices in Rancher, and I'm going to talk a little bit about what are microservices for anybody who's not familiar with that. But more importantly, how do you define a microservice? What is the right what are we talking about when we're talking about a microservice, and within a Rancher context, what does that look like? From there, we're going to go right into some demos. And Darren has been working on a pretty cool demo he's going to use in a music sharing application to kind of show how you can deploy a service, and not just deploy the service, but you leverage things like service discovery, configuration management, metadata, upgrade services, Route 53, all sorts of different types of things to make it available, to manage it better, and to configure it better. So we're getting into the whole purpose of today's meetup is to get into the weeds. The hope is that most of you have some familiarity with Docker already, because we're not going to be doing a lot of Docker 101 today. It's really going to be how do you actually deploy stuff into production with the expectation that these services will be either standalone or part of a bigger application mesh. So we'll be talking about that. We'll end with a couple of our standard points, just the latest updates on Rancher. We spent about 5-10 minutes talking about some of the cool new features that have been added, and then we'll talk a little bit about how to get started, to join the beta, to pull everything down from GitHub and set up your own Rancher if you haven't already. So, with no further ado, I'll just a little bit of background on Rancher, Rancher Labs. We're a startup. We're almost 30 people now. Our team is split between California and Arizona. We have some people around the world as well. And fundamentally, we make two products. We have Rancher, which is a software platform we use for building a private container service, and this is what we're mostly going to talk about today. And we have Rancher OS, which is a 27 megabyte micro Linux distribution that it uses Docker as PID1 and is a great minimalist open operating system for running your containers. And we're not going to talk much about Rancher OS today. Today's focus is going to be on Rancher. So when you think about Rancher, the best way to think of it is it's an open source platform, and it really is designed for building your own private container service. And a private container service is kind of like a public container service. If you think of like Amazon's Elastic Computing Service or Google's Compute Engine, these are platforms that are designed to run on top of those specific clouds and make it easier to run containers. Rancher is sort of the same thing, but it's designed to run on any infrastructure and make it really easy to run and deploy containers. So what that means is, if you think of Rancher as sort of a series of functionality, it's basically a platform that you deploy on top of whatever infrastructure you like, or whatever combination of infrastructure you like, and you then populate what we call environments with resources. So an environment is like a security zone or an availability zone. It's a set of resources that are isolated from other resources, and each environment takes whatever hosts you want to add into it. As long as they're running Linux and can run Docker, they can become an environment within a Rancher deployment, and it then implements everything you need to run your containers really well. So it brings in a full network implementation across hosts. It brings in the concept of storage services, which we'll talk about a lot today. It brings in user management and multi-tenancy. It gives you sort of ops management and manages sort of capacity, what your availability is in each cluster, schedule. It supports really 3 modes. You run it in just native Docker, so you can run Docker on all the hosts, and Rancher does the scheduling. And just now we've added support for Swarm and Kubernetes as schedulers, so you'll see each of those come into the open source project over the next couple of releases. And then all of this gets used to deploy your applications, and you can deploy those manually or from Compose, or even through the Rancher catalog, which is a management platform that sits on top of all this and makes it really easy to deploy out whatever services you want. So we'll talk about all of these things as we go through today, but I don't want to spend too much time talking about Rancher. My real focus today was to dig into this concept of microservices, and what is a microservice? How does it differentiate from your traditional monolith, and how do you use containers to manage these things? The best way to think of the transition that's happening as we move from sort of monoliths to microservices is that historically, if you had a set of applications or a single application, you would have lots of different pieces of functionality sitting at each layer of the stack, and you'd have teams defined to actually manage that. So you'd have your web team, and they would manage a bunch of code and certain functionality at the web tier. You'd have an app team, and they would manage bits of code, and you'd have a data team, and they would manage their big databases. And this was best practices for building applications for a long time. And there's a lot of good things in this, in the sense of, it allows people to specialize and become really experts at how to run a database, experts in using Tomcat and Java, experts in JavaScript, experts in different functional languages and capabilities, and you got a lot of this knowledge that was built up in terms of how to manage your applications. And when you scaled it out, you just scaled it out horizontally. When you needed more capacity, you scaled out more web nodes. You scaled out more app nodes. You bought a bigger storage backend to use more database. And this was sort of the standard architecture for applications for a long time. What we're doing with microservices is we're trying to take these individual components, right, the functionality at different tiers, the functionality at different levels of the application, and spin it out as its own service, and a service that combines all of the required functionality necessary for that service to be resilient. And then we allocate cross-functional teams to manage that function and to deliver that function and to be responsible for that function. And the goal is to, in a lot of ways, the biggest goal is to shift away from, sort of this train-like development where each team seems to always be waiting for one another, because the application cycle times are so long and because there's so many moving pieces, it becomes difficult to rather iterate on smaller pieces and develop those smaller pieces more rapidly, and focus on the stability and the functionality and the usability of those services with integrated teams that handle the entire life cycle of that piece of code. And then, allow these functions, these sort of standalone pieces of functionality, to connect to each other, to discover the features they need, out there, and to understand, their dependencies, both upstream and downstream. Who uses me? What is the impact of a change? Who am I consuming? What is an impact of a change there? So that systems can change a lot more rapidly and understand their dependencies a lot better, but that individual teams can own that responsibility for themselves. So if you think of the real benefits, as you move to microservices, you have more well-defined architectures. You understand, the ownership of the actual functionality that you're developing. So you have teams that are quite specifically allocated to delivering functionality, so there's accountability. You have much faster innovation cycles. That's really the end goal, is that you can push code much more frequently into a service because you understand what will impact and what will not impact other people. So fixing a bug, improving performance, enhancing some capability. You can do all these things. Systems talk generally through APIs. You almost always reduce your failure domain so that a single service may fail, and that may have implications, but it'll be very clear which service is failing. So you're much easier. It's much easier to actually do root cause analysis and understand the implications of of a failure that's impacting users. And then a big one of these is that individual services now can scale. So you're also able to save a lot of money by not scaling up necessarily everything to meet the demands of your application, but rather servicing individual components. There's another big key benefit that people tend to realize as they develop this, is that it becomes a lot more reusable functionality. So as you develop, user management system or a logging system or something, you may find that these services are generally applicable as opposed to applications applicable. And so services can become, consumed by lots of different applications or lots of different functionality. So this is kind of the concept of microservices, breaking down these functional lines into specific roles. And when we think about what a microservice looks like in a Docker world, it's very often that a microservice will have its own data set, its own application servers, maybe its own load balancers, and be delivered as a series of containers defined by something like a compose template. So we're going to spend a lot of today in Compose, showing how to, define your services, to link services, to build in resiliency and availability into services, to upgrade these services. So this is really the focus of today's discussion: how to how to think about the compose file, how to build your compose file, your application architecture for a microservice, and roll that out. The things we're going to cover as we go through this are pretty tightly aligned with sort of how you'd use Rancher. We're going to start by kind of covering how do you define and your service, and what are the images that make it up, and then how do you configure those images, because often you're going to use standard implementations like Tomcat latest, as I have here, but you'll want to throw your configuration files in there. So we're going to talk a little bit about the concept of Sidekicks and what is a Sidekick, and we'll talk about Conf-D and pieces of technology that we use to deploy services and implement them with specific configurations while continuously using maybe the latest version or a standard version of your containers. So we'll talk a little bit about best practices there in terms of how to define an individual service or a piece of a service. We'll then talk about dependencies and service discovery and how these services really never live in isolation. So we'll talk about within a service how you define the dependencies of a service, how you connect my Tomcat to my MySQL in this case, or to your MariaDB or whatever it is you're using to deploy your data set. And we'll talk about the concept of service discovery both at a sort of service level, and then we may cover it a little bit at a macro level. So as you're thinking about connecting your user management service with your web front end, we'll try to cover that as well. We'll then hit on sort of the kind of one of the key pieces, which is how do you then schedule your workload, how do you scale it, how do you build it for high availability, how do you set up things like health checks, and we'll go through all of that. We'll talk about those pieces as as you think about not just making your service available in a single container, but then load balancing that service, defining health checks for that service, even load balancing your load balancers using something like Route 53 and global DNS functionality. So we'll dig into that, and we'll go through that, and then I think we're gonna end it by showing you how to upgrade your services. What are the different models for upgrading? What is an in-place upgrade versus a rolling upgrade versus a blue-green upgrade? So we'll go through and cover all of those things as Darren has time. There were a couple questions that popped in as we were talking. One of them was about Rancher's target environment. So what is Rancher's target use case? Rancher is really targeted at anyone who is looking for a complete simple to use stack that is open source, imports multi-tenancy, and provides a full implementation of all the functionality you need to deploy your containers. So it's used by just about every kind of company you can think of, from web companies and web designers and startups to some of the biggest banks and government agencies in the world. It's currently in beta, so Rancher's in beta right now. It'll be GAing later this fall, and when we GA it, we'll also make sort of enterprise support contracts available. So that's kind of how we as a company are going to try to make money. In terms of, there's another question asking about orchestration tools, and asking whether Nomad was going to be, were there any plans to support Nomad for orchestration? Right now, we don't have that on the roadmap. I don't think we're seeing any demand for it. There's one or two companies that I know of who've mentioned it, but right now, I would say Swarm, Swarm and Kubernetes are definitely some of the areas where we see a lot of demand, but Nomad might be interesting depending on if we see more demand for it. Obviously, it's pretty new, so we'll kind of look and see what's available there. With that, I'm going to turn it over to Darren and let Darren sort of cover some of this in more depth. So, Darren, I'm going to make you the presenter. Give me 1 second, and you can get going.
All right.
Okay, you should be the presenter. I can see your screen. It's working.
All right. Okay, so I'm gonna demo the kind of the full life cycle here of what it kind of takes to start with like a very simple Docker image, something you might be able to pull from Docker Hub, and then turn it into like a real production thing you can run. So this is kind of my cheat sheet here. Basically, I'm going to go through defining the services and the scheduling, set up a database, set up configuration management. We're going to use some shared storage. We're actually going to deploy Gluster. Set up the scaling, load balancing, some DNS integration with Route 53, set up a friendly CNAME, SSL, then upgrade and rollback. So this is going to be a pretty long demo. It's going to be pretty crazy. I'm going to make a lot of mistakes, I'm sure. So just bear with me. So what we're going to do, we'll start off with the UI, and then quickly we're going to move to, basically we're going to move to the command line. So I'll be doing the majority of this with Rancher Compose and editing files, and then we'll kind of flip back and forth between the UI to see things, and then sometimes it's easier just to find things, kind of figure out how things work in the UI. So what we have here, what I'm showing is this environment I already set up. I have 6 hosts. Each one of these big green boxes is a host. I've registered. I think these ones are all on Google right now. But I've gone through and I've created 6 hosts, and I've tagged them, 3 of them as web equals true and 3 of them as DB equals true. So we're going to end up that later for scheduling. But so this is the basic environment that I'm working with. And then the app that we're going to be fooling around with today is called Apache. And you basically can host like all your files and then stream all your music files and then stream them. So this is just something I just actually started playing with this yesterday.
Do you want to show people the website so they know where to find their own Apache if they decide they want to pull it? I think it's ampache.com, wasn't it? Or org. There you go. So if you decided you want to follow along at home, you can, or you want to become a music streaming, guru, you can try out Apache yourself. It was pretty fun. We got a kick out of it. You'd also, if you want, I think you can find a deployment in Docker Hub.
Yeah. Okay. So yeah. So
before you move on, Darren, there was a question about what version of Rancher this is. I think a lot of people noticed the new UI. I got a couple of what is this? Why this doesn't look like my old Rancher UI? So,
right. Right. So what I'm demoing is what is going to be released today or tomorrow. I'm not exactly sure on the date. Let's say tomorrow. So this is the new UI. This is what we showed off at DockerCon. This is a lot of the features that we showed off at DockerCon, especially around the storage stuff. So everything you see here will be in the release tomorrow. This is and like nothing here is like definitely going in the release tomorrow. I'm running the actual like the RC. So that will be.
So this will be 0.47 then, for those of you who don't know. Yeah, 47.
Yeah. So 46 is our current release. 47 is coming out tomorrow. Okay. Right. Okay. So what we're going to do is we're going to start off and we're just going to deploy this application. So the way I'm going to do this is I'm just going to start with like a simple thing, very simple, how you would kind of, what you would see like in just like a demo or a blog or whatever of like just run this long command and you get the app up and running. Like I'll just start with something simple and then we'll just keep getting more and more complex and adding more things. So what we're going to do is the way Rancher groups things is we have what are called stacks. Stacks are groups of services, and services are groups of containers. So basically, we're going to create a stack. So this is going to be kind of like the stack that I use for Apache. We're going to call it Apache. I'm not going to upload a compose file or anything. So it's just going to start with an empty stack. So right now, there's basically nothing in it. I'm just going to add a service, and we're going to start. We'll call this Apache. And we're going to use the image that's just available on Docker Hub. So just Apache, the latest one. Now, what I'm going to do is I'm going to define some scheduling rules. So as I showed before, I have the various hosts. Some of them I tagged with web true. So those are the ones where I'm going to want the Apache to run on those web servers. I've decided, maybe those are like smaller, cheaper machines. So the DB true ones, those ones have faster storage. Or, usually you can run your database on a little more costly infrastructure. So, we just kind of separated that out that way. So here in the UI, to do the scheduling, it's often the easiest to figure out the scheduling rules from the UI, and then we can export it out to a configuration file afterwards. Or if you want, you can always go to our docs, which is docs.rancher.com. Most of the scheduling is here in the Rancher Compose section. It talks all about all the various labels and how the scheduling works. But again, we're going to go with the UI here. So we're going to add a rule in which we're going to say the host must have a host label of web and then value true. Okay, so that's going to put that onto the web nodes, and then additionally, we want to map a public port so we can actually get to this thing from the internet. And then so we're just going to go and we're going to create this. Okay, so when you get to create, it doesn't actually start it at that time, so we're just going to click start. So now you can see it's activating the services coming out. So that's up and running. And this new UI here, we now have like nice links. So this is on port 80 of that one host, so I can just click there and go. So now I have this Apache up and running. And the way this app is, it has this nice little wizard for setting up the system. So we'll just go through this. I'll show you what this looks like once, and then we're going to end up kind of automating a lot of this later. So you can see the MySQL hosting is localhost, like this container that you get from Apache actually has MySQL running inside. So all we need to do is basically create a user. We want it to be Apache. We're going to have to configure this again. You know, this step's not like super important what I'm doing here. This is just the step to getting this application working. I just want to show you what this looks like, and then we're going to kind of tear it down and start over again, you know, doing this in a little bit more production-friendly approach. Okay, so okay, almost there. Okay, so after all that, basically, I have this up and running. So this is a great thing about Docker. There's a lot of apps you can find like this that you can very quickly. Let's see why it's taking so long. We'll give it a second. I'll log in. There's a great thing about Docker. You can find a lot of images available. You can quickly get applications up and running. Very, takes very minimal effort. I have this thing running now. But there is a series of problems with this. You know, anyone who's to put these applications into production, you realize, okay, well, we're actually running the database in the container. That's not very great. What happens if I want to upgrade it? Am I going to lose all the data? How do I actually scale this thing? It's not using SSL. How do I manage the password? I mean, there's just all these different things, like how do I actually get this into production? So while it was great, I could get this up and running really fast. Let's actually kind of go back a little bit and, deploy this in a way that we, really think is like, production worthy. We can actually manage upgrades and everything. So one of the first things we're going to want to do is actually pull out the database. So we don't want to run the database in the container. While that was like really convenient, not the best way to manage it. So what we're going to do is we'll go and create another stack specifically for the database. Now I do have the option, like within this Apache stack, I could just go here, say add service, and add another, add MySQL here. And that kind of works, but what we've kind of seen from a best practice, people kind of want to separate out the concerns to different stacks. So the database, you're going to put in your own database stack because it's most likely managed separately. You're going to do upgrades separately. It might be a different team that's interacting with it. So it doesn't make a lot of sense to kind of put it in the same stack as your application. So we're going to kind of follow that paradigm. And instead of doing this from the UI here, we're going to go to the command line. And so what I'm going to do, I'll just create a stack which is going to be called, we'll call it DB. By default, Rancher Compose will name the stack the same as the folder name. You can use -p to name it something else if you want, but by default, it's the folder name. So we'll just stick with that, make it easy. Okay, so I do have a kind of a cheat sheet here of a Docker Compose file that I know actually works, so I don't fat finger too many things. So what we're going to do is we're just going to create a Docker Compose file here, Docker Compose. Oops, that was not very good. Okay, So basically, there's one thing I'm going to kind of punt on in this demo is secrets management. I really wanted to get secrets management in. When I kind of did the whole demo, it just ended up being too long. So what I'm doing here with this running MySQL, this is not a best practice. You really should not be putting passwords in environment variables. But this is the stock MySQL image, and it's how they do it. There's much better approaches. Most people are kind of converging towards doing something based off of volume drivers because you can just basically read it what looks like from disk, but it's in memory and it's secure, it's encrypted, and everything. So that's probably a meetup in itself to go over secrets management. So I'm kind of going to punt on that. We're just going to do this approach. But again, not best practice to put username, password, and environment variables. Okay, so I have MySQL. So we're just going to go and we're going to just deploy this file. So if I just say, Rancher goes up, I go back to the UI here. Okay, so if I go to the UI, we should now see. Okay, so the database came up. I've got that running. Okay, so that's simple. We have a database. So now the next thing is we need to connect Apache to that database. So at this point, we're going to stop using the UI for the kind of how we were using Apache, but we're going to just go to start messing with the configuration. So here, I'm just going to copy this and create a new Docker Compose file. Docker Compose. And please, if anyone has any questions, stop me. I'm probably going to be going on for like an hour talking, and I'm going to get bored myself if I just keep talking. Okay. These, I'll tell you, like the UI by default puts these in. These are not needed for the vast majority of images. The TTY true and stdin open true. So I'm just going to delete those. Okay, so this is what we already have deployed. But now what I want to do is I'm not going to use the MySQL that's in there locally. I want to use the MySQL that I just deployed. And since it's in a separate stack, we use external links. We say external links MySQL. Sorry, let me make sure. Go back here. MySQL. Oh, I called it DB. Sorry. So this is DB, and then MySQL, and we want to name it as MySQL. So that will link. What this is going to do is going to link this MySQL application to this container, and it's going to be available under this DNS MySQL. So now I'm going to go and deploy this. What I'm going to do first is I'm going to delete it, because since I went through that wizard, it already configured the application. So I'm going to delete this now and then redeploy it so it kind of wipes out the configuration. Okay, so we should see, yeah, so now if I go to this stack, there's no service in there. If I go now and do an up, this is now deploying this, and you should see, yeah, so it is now linked. I now have Apache. It is now linked to MySQL. I clicked on that. This is the service that I deployed. Let's go back. So now if I go through this, let me go through the wizard again, like before what I had done. This is what I ran last time. So the difference here now is I can use instead of using localhost, I can use MySQL. So this is how we do the DNS-based service discovery. So the database can be wherever it needs to be. It could be in RDS. We could have deployed a Galera cluster. We could deploy the simple MySQL that we just did right now. It doesn't really matter where it is. It can be managed by Rancher or not. We just make it available as this DNS name. So all that the application needs to know now is just MySQL. And in fact, we can just pretty much hard code that. And the next step, what I'll be doing is actually doing the configuration management for this. And I'll show you how we pretty much just hard code this name MySQL, because it doesn't really matter. It doesn't need to be configurable because at runtime, based on service discovery, it will resolve to the right service. So if I go through this installation again, database. Oops. Oh, oops. I think there was already a database. MySQL username, password. Oh, sorry. Wrong hostname. MySQL username, password. Try this again. Right. That worked. That one worked. This one worked. Alpha. I never created. Okay. I kind of messed that one up. See, recheck configuration. See what happens. No. Okay. I'm just going to wipe it out and do it again because I must have clicked through that wizard the wrong order or something. Not a big deal.
I love how easy that is. It's just destroy and restand it up.
Yeah, and so, well, because what I'm trying to show here also is kind of the fragile nature of this is I'm running through this wizard, which is really not like the best thing. Like, obviously, if you're deploying something into production, you don't want to run through a wizard like this. You really want to do this properly through configuration management, and that's kind of the next step of what I'll do is actually the configuration management, so we don't have to click through this thing anymore. So let me see if I can get this.
So it's fair to say right now, you've deployed the first application with everything combined. This application now you've split the database out, and you're still manually managing the connection between the service and the database and the configuration of Apache. And you're saying next you're going to go and spin out that configuration and start using configuration management on the containers to sort of eliminate the pain of doing this piece as well.
Exactly. So let's see if this works this time. If it doesn't, we'll just go on to the next step. Not a big deal because we're just going to automate this anyways. Oh, no, it worked. Okay. Woohoo, it actually, wait, yeah, and then create an account here. And then, okay. Okay. This is still doing all the database upgrade stuff. Okay, so again, now what I have is we now have a little bit more robust of an application because we've actually separated this out. We now have the Apache container, but we're using a separate database. So now we can manage the database, separately. We can do the upgrades. The data is not in that one container. But as I've kind of pointed out as I'm going through this wizard, one of the problems is that all the configuration is still in the container. So if I was to delete this container and then deploy it again, I'm going to have to run through that wizard again because it just lost its state. So this is where we need to end up pulling in configuration management. So let me show you how we're going to do the configuration. Okay, so this pattern, so I have on standby here Bill Maxwell. He's really our guru in this area, putting together all these containers. I do want to point this out. If you go into GitHub, you go to our Rancher repo. We have Rancher Rancher catalog. Actually, I haven't shown the catalog yet. I'll show it in just a second. But Rancher catalog has a series of kind of pre-banked templates and catalog entries that we have. If you look in there, you can see various applications. Bill's put together a lot of these, plus we've had some contributions. So you can look into the Rancher catalog, and then additionally, if you go to Rancher Compose Templates, the source for pretty much all these templates are in here. So in here, you can find like how we actually built the containers and everything. And the reason why I'm pointing this out is what I'm going to show you today is it's pretty advanced. I'll walk through it, explain as much as I can, but it's really good if you can look at a lot of the examples and the things that Bill's already put together, because he's had to cover all these various different ways of configuring these applications, setting up clustered systems, and you can find tons of good examples in these compose templates. Okay.
Hey, Darren, on that note, there was actually a question that had come up a couple minutes ago from Richard Silver. He is asking if in the future you might be able to manage Docker Compose and Rancher Compose files in the catalog instead of needing to create them in the CLI or on Rancher server. I think the plan there, Richard, is that you'll be able to manage your own catalog and deploy, connect it directly to a Git repo like what Darren showed. So very soon, within the next couple releases, you'll have not just the Rancher catalog, but you'll have the ability to attach your own catalog manage those, because it's really just the Git backend that we're talking to. Do you want to elaborate on that at all, Darren?
No, I was just showing the catalog here. So our catalog is backed by Git right now, and we will be pushing out the functionality to have like multiple catalogs so you can manage your own. Yeah, that's it. Okay, so now moving on to like kind of the configuration management aspect, like how we're going to do this. So basically, we have this pattern that we've kind of developed where you have a container. So we have this container from basically kind of our upstream container, Apache. We don't really want to modify that container directly. We could just put a bunch of files. We could just put a bunch of files in, create our own container, but it kind of it kind of decreases the flexibility of that container. It also makes it a little harder that whenever there's a new version, you have to then rebundle that one. So we've come up with this pattern that we're using Sidekicks and basically volume sharing to manage the configuration of an existing template or existing image. So the way we do that is basically by creating two sidekicks. Now let me explain what a sidekick is. A sidekick is basically when I deploy this service, so I'm Apache, this creates one container. I can go and I can scale up that service. So I can go into here and say, okay, I want 3 of these. If I just hit +1, I'll get 3 of those containers, and that might go to 3 different hosts. What a sidekick is I can make it so that a container always gets deployed next to one of these containers for the service. So if I have 3 Apache containers running, and each of them had a sidekick, then it would deploy 3 additional containers, and they would be scheduled next. So wherever it lands, you put one right next to it. And so this is where you create these kind of deployment units of multiple containers that can interact with each other. So if you're familiar with Kubernetes, this is basically right along the lines of a pod. Okay. So what we're going to do is we're going to create two containers. One we're going to call Apache Data, and the next one we're going to call Apache Config, like CFG. So for the Apache Data, this is where we're actually going to store the configuration files that we're going to manage. So when we do an upgrade, we can upgrade the configuration management scripts, or we can upgrade the actual software that we're running independently of the configuration. Like all 3 of them could be upgraded to manage separately. So the role of the data container is really just to hold the files. Now, as named volumes become more popular and more widely used, this pattern will probably move towards named volumes. But there is some little scheduling gotchas around named volumes that people don't realize, and so right now it is still the best pattern to use data containers. So since this is a data container, we don't actually care what's running in it, like the actual code. So we're going to use this one image called Tian True. Tian True is a really, really small image. It's actually written in assembly. It's probably about the smallest image you'll find, and it just basically it just returns exit code 0, like true, and exits. So we don't actually need this container to do anything. It's just going to store files. Additionally, since we don't need it to do anything, there's no reason to have any networking on it. And then the key thing of what we really want is the volumes. So let me go back to cheat sheet here of where I have this actually working. Let me just copy these. Okay, so the volumes that I actually need. So I've looked at this application. I've figured out where are my different configuration files, and they're going to be basically in these 3 locations. So I create 3 volumes there. So once I have those volumes here, I can now on my main service say volumes from. Say Apache data. Okay, so the Apache container is now going to share these directories. So anything put into those directories will be the same thing in the Apache. So this is how we can now override these directories that are from the main container that we're getting from upstream, but we're going to put in our own configuration files. Now there's one little gotcha that you need to kind of remember with these containers from a rancher perspective is that, let me open up this file I had. So there's this one label that's kind of important. This label here says start 1, because this data container is going to start and then exit, and then we're just going to use what's on disk. So we don't want rancher to keep restarting. So we have this one label here of restart 1 equals true, or start 1 equals true. Okay. So now we basically set up a container where we can store the configuration files. Now we need a container which will actually manage the configuration files. And this we do with conf. That's what we found. You can do it with shell script. You can do there's various different ways you can manage the configuration. We found conf works pretty well for what we need. Additionally, we've integrated that with rancher metadata. So let me exit here, and I will show you this container that I've built to do the configuration management. So if I look at here, I have these files. These are the files that I figured out for this application actually need to be managed. There's something important in there that might change for environment or has some configuration. So kind of the key one here is going to be this Apache Config Php. So let me open up this file. Okay, so this is a conf template. So this is using kind of the conf configuration syntax. It's basically a Golang template, but the special functions that conf exposes. And so what we're going to do here is we're going to say, okay, the database username and the password, we're going to pull these from metadata. Because that's really the only thing that's required right now that I need to configure, is these need to come from metadata. So what this is doing is it's talking to the rancher metadata. So let me talk a little bit more about what that means, rancher metadata. So if I go here, I still have this container running, this Apache container. Let me go to the service, you can see I have a container here, this one container. I can go and drop into a shell. Let me go into the shell here. Let me make sure curl is there. There is no curl. Hopefully it's going to apt-get install curl. Okay. Oops, apt-get update. That is not moving very fast. 47. Whoa, really slowing down. Okay, it's almost done. Okay, so I'm in this container. I'm going to run curl because I'm going to show you what I mean by the rancher metadata. So let's see, curl. Okay, curl there. Okay, so whenever you deploy a container in rancher, we automatically set up this metadata service. If you're familiar with EC2 metadata, it basically follows the same approach. But what it is you can hit curl. You hit a well-known location. Since we're managing DNS, we just set up the DNS name for you. And you can say like self-container, something like this. This will give you information about yourself. So you can say like self-container host name. Oops, why did that close? Shoot. Open that back up. Not quite sure why that closed. Let me just restart or refresh if that helps. Okay. So I can say like brancher, metadata, latest self container. That's what I had before. So you can find out some things like what stack I'm in. My stack name is going to be Apache. And then I can also say self. I can look, okay, what's it, look up information about the stack. So I can say self stack, what environment I'm in. But one of the key things is actually what we're going to do is self stack metadata. Now I haven't set any metadata on this current service, so it says not found. But what we'll do in this example is we'll actually set the metadata. So this allows you to put in some structured data, some information that you might want to attach to this container, and then at runtime you can pull this in. So we're going to use that for like username password, which is really not the best practice, but in metadata, one of the most common things we're using metadata for is to pass in like additional configuration files and things like that. Like, for example, if you're deploying a Logstash container, like the configuration of Logstash is very specific to the application, so you might want to put in snippets of the configuration into the metadata, and then you can pull that in. Okay. So let me go back to here. So what this is doing, what we see here in this template, what this is doing is just calling metadata, kind of the curl, what I was typing on the command line, but it's just going through conf and everything, is it's doing self-service metadata DB user. So it's going to pull in that value and stick it into this file. Okay, so I've already gone through and built this Docker image, pushed it out. So basically this Docker image has all the files I'm going to manage. So if I go back to my my example here that I'm working on, so let me go back to the cheat sheet here. Copy this, and I'll show you. Okay, so this is the image that the files I was just showing, they're in this image. So I just pushed that. Sorry, so I've already pushed that out there ahead of time. So a couple things, we're gonna do net container. The reason why we're gonna do net container to the reason why we're going to do net container to Apache is if you do net container, then basically this container, when it looks up through the metadata, it will act as the service. You can get information about service. If you don't do net container, it will get information about itself, which is still possible to figure out other things about the container, but it's a little more straightforward, we found, for people when they're writing these scripts and everything. If you just do net container to the primary service, works a little better. So again, here at the bottom, we're going to do volumes from. So volumes from is we're just going to share this container. So both Apache and the Apache config are both using volumes from the data. So that's kind of like the intermediator. So the config is putting things into the config container is putting things into this directory. This guy's reading things from this directory. Okay. So I mentioned the metadata. So we need to actually set the metadata values. So that we put into the Rancher Compose file. So let me just flip the Rancher Compose or open that up. So we can do Apache, and then we just do metadata. And the values I was looking for was DB user. It's just going to be Apache. And DB pass is going to be Apache. Okay, so when I set these metadata values here in the file, they're going to be available from the metadata service when I deploy. Okay, so now if everything works, this should deploy and come up. We'll see. Close that. Okay, so what I'm going to do, I'm just going to delete what we currently have. So I'm going to say branch compose RMF. So I'm just going to delete the this will delete the Apache container. Yeah, okay. So, sorry, if I go into the service here, we have no Now if I do up, now this will be the trick if this works on the first try. Invalid reference field name, Apache, launch config. Okay, so launch config name, invalid reference service. Okay, so oh, I forgot the most important label of all. Okay, so the reason where it said invalid reference, so you can see here in net container where it says Apache, the only way that you can end up using that is if it's a sidekick. So I forgot to define the actual sidekick, which is kind of the most important part here. So we're going to say sidekicks here, and we're going to define Apache data and Apache CFG as sidekicks. Okay. Now we'll try it again. All right, that seems to be going a little better. So let's go back here. Let's make sure these things come up. So you can see we have the Apache with 2 sidekicks coming up.
Hey, Darren, while you're doing that, there was a question, a couple questions that came in, so I'll let you, take a break for a minute. One of the questions was from Ankur Seti, and it was a good question. He asked he said he has an application which references a linked container with a Docker Compose command, but in Rancher cannot reach the linked container on startup because the DNS is not ready. When does the DNS get ready for Rancher at runtime or startup?
Yeah. Okay. So yeah. So this is something where we're going to address shortly, because basically before Docker 1.9 had the volume plugins, we kind of had to come in behind the scenes and set up a lot of the networking. So the effect was that a container would come up and we wouldn't fully configure the networking yet. So what we're doing in Docker 1.9, this will all be addressed, that when the container starts, everything will already be guaranteed to be up and running. So what we typically tell people to do right now, which I know is not the best solution, is in like kind of the entry point of your application, just put something that calls Rancher metadata, so that Rancher-metadata URL. So if you just kind of like ping that until it works, then start up your application, and then you're guaranteed that everything, as soon as you can hit that, then it'll work. So the reason why this happens is it's not that we haven't set up DNS, it's because we haven't edited the resolve conf file. So when the container starts, we edit the resolve conf right when the container starts. So there's this little race condition. You see it a lot, like with let's say Go microservices that run as PID1, because they start up so fast. They try to do a DNS lookup before we can get in there and change the file. Typically, like on the second start of the container, it'll work, but that's not always the case. So we will be fixing that. That's a major thing that I'm working on right now. It's kind of revamping all of our stuff into the Docker 1.9 network.
Great, thanks. And just as we're hitting the hour-long point, we still have quite a bit of this to go. So just a reminder, we're recording everything. If you do need to disappear, don't feel bad. There's another question that I'll try and take while you were doing something, Darren. Charles Corbett had asked, he was saying he's found it hard to really adopt usage of the Rancher Compose CLI. Maybe he's having a honeymoon period for the UI. Will there be more documentation with examples of usage in sort of day-to-day of the CLI? Charles, you and I are on the same page. I prefer this UI as well. I tend to just, whereas Darren kind of only uses the CLI. So I think there's a certain amount of just comfort level in what you like to use. I found the UI to just be very easy and quick to do things. But I know we are doing some work to extend the CLI and to make it easier to, we're putting together more documentation around it, and also we're going to start posting some, we have a new learning section coming up on our site in the next week or two, and we're going to start posting some videos and examples of how to use the CLI. So yeah, if you have ideas as well of things you'd like to see or something specific, just shoot them over. You can always email either of us at firstname@rancher.com. So Shannon at Rancher, Darren at Rancher, with things you'd love to see. We're all listening. Thanks for the good question. Okay, there was one last question from Richard, just asking about. Oh yeah, go ahead.
I was going to
Did you want to?
one comment about the CLI. What I was going to say was when we created Rancher Compose, it basically, the design of Rancher Compose was basically it's just supposed to be Docker composed. Like, so the interface and everything was supposed to be, specific. I mean, it was basically supposed to mimic Docker Compose. And kind of because of that, we didn't really document it, which was not a great thing. But we're investing a lot more in the CLI. There's a lot more functionality coming to the CLI. And so as Shannon said, you will see a lot more documentation around it.
Then Richard's question was kind of onto this config stuff. So he was saying, are you suggesting that Rancher is modifying the contents of the container for resolve.conf, or did I miss something subtle? So Darren, you want to tackle that?
Yes, we actually modify resolve.conf file of the container. It depends on the flow of how. It depends on the flow of how you launch the container, because you can launch things in Rancher like going through Rancher, or you can launch things from the command line, just doing docker run, and then you add a label to say that you want Rancher networking. Like, that will become a network driver. But depending on the flow, we don't really have the ability to kind of properly set the DNS. So we do kind of go behind the scenes and modify that file. That's what we're trying to get away from, is we're trying to do this much more proper, so we won't modify that file.
Great, thanks. Okay, off you go.
Okay, so what I wanted to show, I think this came up, but I wanted to show, so what I've clicked here is I've gone to, when I click on the service, and click this little I here, and you can see this is the primary service, and I have two sidekicks. So those are the two containers that launch. So the config one is where it's running config-d, and when I look at the logs for this config container, I can see that it actually generated these configuration files for me. So it looked and said, oh, it's out of sync, and then it updated it. And so this is kind of what config does, is it looks at the Rancher metadata, it looks at the template, it will generate the configuration. If the configuration is changed, it will then put the new configuration file in place. And then you have the ability to do like post actions, and we're going to be adding more hooks into config, so you can more easily like restart or do a sig hop on different containers. So let's actually click on the service and see what happens, see if it actually came up. We'll click here. Okay. Give it time to think. Give it a lot of time to think. Okay. All right. So what happened there, it didn't seem that magical, but I actually deleted the old Apache container, and then I just brought this up based on configuration management. So now I didn't have to go through that wizard. It's already configured for me. And now as I scale up the application, as I do 2, 3 of these, it will now be pre-configured. I'm not going to have to worry about the these assets that before had to be placed in the var www config folder. So now we have so at this point, basically what we've done is we have Apache running in its own container, talking to a database, and then we split out the configuration management into 2 separate containers. So now we have full configuration management of this service talking to a database. So then kind of the next step where we want to go is we want to do load balancing. So in order to do load balancing, basically we're going to deploy a load balancer. Now again, what we've found among users is they tend to like to set up a stack dedicated for the load balancer, or load balancing. The reason for that is most applications you can just keep on the private network. And then when they actually need to go out to the internet, you just create a load balancer, and that's kind of your entry point into the application. And so since a load balancer needs to belong to a public port, that's kind of a sparse resource. You only have so many public ports, because you only have so many port 80 and port 443, basically, pretty much one per VM in most cases. So you kind of want to manage the load balancer a little, little bit more special, because it needs to use public ports and IPs and DNS and whatnot. But then you can let your applications just those can be deployed over and over again as many times as you want because it's just all on the private network and you have plenty of piping space, everything. And so what we're going to do is we're actually going to create another stack for the load balancer. And again, I'm going to do this through the command line. That is kind of my preferred approach. So what we'll do is I already have, well, actually, you know what? Let's do it through the UI because it's a little, this one, so let's add a stack. We're going to create a stack. We'll just call it LB. Don't need to start anything. So create. Okay, so here we're going to go and we're going to add a load balancer. Now the reason why I'm going to do the through the UI is because the configuration gets a little bit more complicated in the load balancer. So the UI, does a much nicer job of kind of helping you through. So I'm going to kind of jump to the bottom here and do scheduling. First off, we're going to want to put these on the web nodes again. So we're going to say this must be web true. So we're going to put this on the host that have web true. Let's go back up to the top here. We just need to call this something. So we'll just call it LB. It doesn't really matter what the name of the load balancer is. You can set what's the scale of how many of the load balancers you actually want to run. So we'll say 3 of them. We have 3 nodes, so it'll run them across 3. Actually, here we'll dynamically scale up. We'll just start with 1 right now. Okay, so here we're going to add source port 80. So this is the port that the load balancer is going to listen on, and we want that to be protocol HTTP. And we're also going to set up SSL. So we'll do port 443. The protocol here is still actually HTTP. You need to check the SSL box if you want it to be HTTPS. There's this other checkbox here for access if you want this to be public or internal. So you can create internal load balancers that are not accessible out to the internet. Okay, so now we want to load balance our Apache. Okay. Oh, there's one part that I forgot. Sorry. The target port. So if it's coming in on port 80, we want it to go to 80. If it's coming in on 443, we actually still want this one to go to 80 because we're doing SSL termination. So the request is going to come in on 443 as SSL, run the, do the SSL termination here, and then the communication will just go over port 80. So we have the target service is Apache, and then if I go down to SSL termination, I already went through, I added a certificate. Once I click OK, I can show you where that is in the UI. But I've already added a certificate, so I can just select that certificate I already have. So if I go, say, OK, save, again, I have to start that. Okay. And then that's active. So just going back to certificates, I kind of glossed over that. In infrastructure, you say certificates, you can just add a certificate. So you can see I put in this certificate before. This is a valid wildcard certificate that I have for this system. Okay. So going back to my load balancer here. So in theory, this should, okay, so this is now, I'm hitting the load balancer IP. And now this is, load balancing to the actual container. So now this, it's still listening on port 80. That's not really needed anymore. So we can just, let's drop the port 80. Let's not have it listed on the internet. So that's basically, means it's exposed out to the internet. Like the application will still be listening on port 80 on the private network, but we just don't need to expose it out to people. So we're just going to go in here and let's remove that. Oops, don't want to cancel that. I'll do that. Okay. Go here, and we're just going to remove this port section. And now I'm going to actually just deploy an upgrade. And I'll talk more about upgrades. Oops, sorry, confirm upgrade. I'll talk more about upgrades towards the end here, but I'm just going to run this, and that's just a quick upgrade of the service, which will drop that port if everything works right. Okay, that's upgrading right now. Okay, so you can see port 80 went away. So now my Apache service is no longer listening on port 80, but there's port 80 on the internet, but it should still be accessible through the load balancer if everything works right. Might take a second because that actually redeployed the application to the, I don't know if PHP has to re-render or something. There you go. Okay.
Darren, yeah, while you're doing that, there was a question that came in, and it was it's kind of a big question, so maybe something we want to kind of push to talk about a little bit at the end. But Peter Minkina was asking about migrating this environment from across stacks. So literally going from, say, like DigitalOcean to Amazon, and managing hosts in a couple different zones. I don't want to sort of interrupt your flow. So is that something maybe we can sort of address that later? I just thought I'd sort of bring it up if you want.
Yeah, maybe across stacks or across environments. Like
I think across environments. Sorry, he's asking about across environments. So migrating to a new environment, and maybe what he's saying is, could you tell us about migrating to a new environment, for example, from DigitalOcean to Amazon, and managing hosts in a few zones? So if we were managing different resource pools.
Yeah. Okay. Yeah. Let's try to get back.
It's a good question, Peter. Why don't we just let's put that one on the back burner, because we could talk a lot about that in a bit. So give us a second. There's another two questions that came in while people had a chance to take a breath. Is there any chance to expose the DNS-oriented routing features of HAProxy to allow us to terminate multiple URLs instead of just basic port-oriented only? That was a good question that came in from Charles Corbett.
Right. That is a great question. So let me show you how that works. So basically, when you add a load balancer here, we have this advanced routing. So what I did was just the basic one. I didn't need any kind of I didn't need any of the advanced routing. But basically, what you can do is you can do it based on the host name, optionally the port. So I can do like example.com, and if I even want to narrow it down to a port, if it's coming in on port 1234, and then also on a path. So I can do foo, and this goes to this one service. But then I could say example.com here. Bar will then go to something else, some other service. Or you don't even have to check the host name if you just want to do path-based routing. So basically, we have both host and path-based routing available. And so this is actually, I probably say, the most popular way to use a load balancer, because again, like, you only have so many public IPs, so it's way better to do layers. Basically, it's the layer 7 routing, so you can reuse those IPs and SSL certificates. So additionally, we support SNI, which is the kind of the SSL equivalent to this routing. So.
Then there were two more load balancing questions. Was it Roman asked, was it layer 3 load balancing only, or any other types supported? So is it just HTTP, HTTPS? Are there any other types of load balancing available?
I mean, basically all we do is TCP and HTTP right now. So TCP is just that's going to be your layer 3 load balancing, but HTTP ends up being like the 4 through 7, which is basically we'll look at the host name to do the path-based routing.
Great. There was another question, and this is from Antonio. Antonio asked, what is the best practice for load balancers in general? Should there be two main load balancers for each environment, and then have an external DNS load balancing on those? Or should it have a stack and an environment have its own load balancer, which is connected to the main two load balancers? I think just any guidance, and I think you're about to show sort of the Route 53 stuff, so maybe it's a good time to sort of just kind of dig into best practices for load balancing. And I think it's fair to say, Antonio, there's no one right answer here. I mean, we've tried to make it flexible enough to let you do different types of things. But go ahead, Darren.
Yeah, and so what we are typically seeing is per environment, people will create one stack, which is for the load balancer. So they'll manage the load balancer from that one environment, and they'll typically run it on like 2 or 3 hosts. And then at that point, you have the option of just using like round-robin DNS, or what also works as a great approach is you put kind of your service provider load balancer in front of that, which would be like ELB, and you just do very basic TCP load balancing. And that provides a very good HA solution. You can do the same thing on a lot of different clouds that have like native load balancing capability. because what we found is, we get a lot more flexibility and control, and we can do a lot better things by moving the load balancing closer to the application. But for full HA, it's still nice to leverage some of the service provider functionality that will come from ELB to do the very basic thing of just GCP load balancing.
Cool. Here's another question on this. It's sort of more DNS, but when we talk about DNS, this is from El Ghazal. I hope I said that right. When we talk about DNS, is there any way to deploy my microservice so it can be reachable internally or externally via sub-domain.domain.com? So,
right, and I think I'll be getting. So let me show you what we're going to do with Route 53 in just a little bit, and if that doesn't answer it, then we'll come back to that question, I think. Is that good?
Only one more load balancing question just popped in, as long as we're on the topic. What do you think about IPVS load balancing compared to Nginx HA proxy?
So IPVS is it's amazingly fast, it's amazingly awesome. I ran it a couple years back, so I might be slightly outdated if there's been more enhancements and whatnot, but it basically works at the layer 3 level. And so while it's ridiculously fast, it works really well as the top layer load balancing, kind of like what I said is like DLB, where it's you do a very simple TCP load balancing, but it doesn't do the layer 4 through 7. And in kind of today's world with microservices and whatnot, is the layer 4 through 7 ends up being super important. So it ends up being a lot better to run HA proxy. So the performance gains you get out of IPVS, what I've seen people do is a stacked solution where you have multiple HA proxies doing layer 4 through 7, and then you do the IPVS stuff up above it to do TCP load balancing.
Awesome. Okay, on you go. I think hold any more questions for a little bit.
All right. So let's see. So I deployed this with HTTPS, but as you see, we kind of have some fundamental problem here. I deployed with HTTPS, but it's an ID. That's no good. The SSL certificate is not trusted. So the next step of what I want to do is actually integrate this with Route 53, doing external DNS. Okay. So right now, everything we've talked about DNS is all internal. We do internal DNS, DNS-based service discovery for the containers, but from an outside world, there's been no integration so far. And so we have if you go to the catalog, this is already available in the catalog, I think in the current version, we have this Route 53 integration. Now, if you want to, if you're programming minded, I would highly recommend actually looking at the code of how we did this. Okay, it's Rancher external DNS, but it's a very small, simple microservice that runs within your environment that reads the Rancher metadata and then just synchronizes it out to Route 53. And we actually have someone just put in a PR. I thought this was really cool. Someone put in a DN simple provider. So it should be easy to add a lot more providers to integrate with other things besides Route 53. But if you look at how this works, the pattern is just really neat and powerful. We've started developing a lot more microservices this way, where we're just basically running things off of the Rancher metadata and then kind of reacting as that metadata changes. Anyway, so let me go through and actually deploy this Route 53. Okay, so what you're going to do is when you go to the catalog entry here, it's going to ask you a couple questions. What's the name of the stack that it's going to create, Route 53? And then basically we now need the AWS permission. So I already have some keys here that I'll use. These are test keys that will be deleted, so don't use them. But let's see. Okay, so I'm going to put that in there, my access key and secret key. what region. Mine's this, I've set up this hosted zone in US West 1. And this zone is called it's going to .space. And the TTL start. So you can see the preview here, the Rancher Compose, basically just deploying this one container. Very simple. Okay, so let's go and launch this. So this thing is starting up now. Let's see. Now, okay, looks like it's active now. Let me just check the logs. We can see if it looks like it's doing things, if it was able to talk to Route 53. Yeah, okay, so this is adding records. So you can see what it already did, like adding DNS record, lb.lb.default.it's going to space. Okay, so this is basically setting up whatever the hosted zone is. So that's what the domain I put with it's going to space. But then the structure that we use is basically environment name, stack name, service name. So lb.lb.default. So in theory, if I copy this, I should be able to access this now through was that the right? Yeah. Okay. So basically what that's done now is all the services that I have in this environment are automatically synchronizing out to Route 53, so now you get public DNS for these things. And in the UI, we will see that you have assigned public DNS names. And so we see the load balancer here. If I click on this, it should, yeah, so like the UI will just bring you directly there. Okay. So now we've set up public DNS. But again, I was trying to get this to run on SSL. So, oops, let me put HTTPS. But now the problem here is still, again, like the certificate I have is not actually for the domain lb default. It's going to space. So what you want to do now is once you have these public DNS names that are kind of auto-generated, the best thing is to do now is to set up a CNIP. And this is, you would just basically go to wherever whatever your DNS provider is. This doesn't have to be Route 53. It could be you're hosting DNS with someone else. But it happens to be this domain. I'm fully hosted with Route 53. So here I can go to it's going to space and create a new record, a new CNAME. I can say CNAME, and this is going to be, we'll just call it Apache. And then the value of the CNAME is going to be LB. So it's the one I have. So I'm going to put the TTL really small just in case I mess this up. Okay. I think that's everything. So yeah, so I see it here, there. So in theory, this should work. And Apache, it's going to space. Yes. Okay. So that's loading up. And now if I want, I can go to HTTPS. And that was a valid wildcard certificate. So now I actually have SSL. So now I have public DNS that's fully synchronized as I deploy my application and I change it and I scale it. If I move it over to different hosts, the DNS will get updated, the load balancer will get updated. I'm using a valid certificate with a friendly domain name. So going back, so hopefully that answers the question on kind of how you can do public DNS, and we're doing we're adding some more features around here to make the public DNS integration easier. So you won't even need like Route 53, but Route 53 was a very simple one to get up and running, and a lot of people kind of already have that set up.
Yeah, we had a lot of people at DockerCon asking about using this with F5, using this with NetScalers, using this with Cloudflare. So we'd certainly welcome other people that want to contribute and have ideas for different load balancers they might want to configure here. But definitely using it behind a firewall with a physical load balancer seems to be an interesting utilization of the same code. There's a question Roman asked that was he was saying, this is really awesome. Could you show AWS console page for Route 53 hosted zones if possible?
Yeah, where did that go? So I'm not sure what it is that you want to.
Maybe show how it's being configured, or if it's
Like
how it's,
how I actually created the hosted zone. So that to create a hosted zone, it's pretty straightforward. Basically, put a domain, my example.com. Yeah, that's not going to be obviously. Actually, I own this one. I build the cloud.com. So you can just go. This creates a hosted zone. Now the key thing here, this is like where it gets like a little more tricky, is whoever you bought the DNS name from most likely set up their own DNS servers so that like when you look up that name, it goes to their DNS. You need to configure that to go to Amazon now. So this value here, basically you need to take these 4 addresses and go to whoever you bought the domain from and configure the name services to be Route 53. Once you do that, then it's all pretty much straightforward.
There's another question Willis had, which was, what if you wanted to configure Route 53 to, just it's going to dot space without a CNAME? Is that possible?
No, not today. I mean, so we didn't want to, so it's, for the friendly URL stuff, we've basically all CNAME based. So you're going to have to create a CNAME, which then goes to where you want it to. I would recommend looking at, kind of your tech savvy like that, looking at how we did external DNS. It's very simple code. If you look at how it's done, you can very easily create a component to kind of create your own friendly domains. To be honest, what we did with Route 53 was actually based off of what one of our customers already had done. So, someone actually came up with this, this approach first, and then we just turned it into an official thing.
Got it. Someone, Charles Corbett, was asking, he was just commenting, I'd love to see an implementation of the auto DNS logic with a simple bind server.
Yeah, I mean, so again, I think there's kind of like a million different integrations that we can do. Obviously, we don't really have time for all of them. We would love contributions. I would be interested in like a simple bind server too. Yeah, so I mean, I agree. We'll see if we have time.
And then there was a question from Joseph Melfi who's saying, for internal service discovery, what does Rancher use to keep that in sync? Is it possible to use console, or is it a fork of etcd or some kind of custom solution? So what is maybe just for our own internal service discovery, Joseph? Maybe I think that's your question. How are we doing that?
Yeah, so for our own internal service discovery, so basically we have our own DNS server which runs on every single host. So we run those across all the hosts. So all the DNS lookups, those are all just local. Now, the way we distribute state is kind of our own mechanism. It's not based off of etcd or console. Just in general, we found the systems to be a little difficult to run, like cross-cloud and to tune and get to work. Like they require a good amount of kind of knowledge on the details and everything. And so we found it the simplest to kind of develop a mechanism of distributing the state that was kind of more tailored to specifically what we're doing. And it's really quite a simple algorithm.
Okay, I think we've got to keep moving. Let's keep going. We're never going to get through all this stuff. This is the point of the mastering class, though, guys. So keep asking the questions. They're great questions, and we're trying to show a lot of stuff in one meetup. So I think we've got maybe another half an hour before we hit 2 hours of content. So hopefully we can sort of go through a couple more things.
Yeah, and so so I'm going to move on to, so basically what's kind of left on my agenda, what I wanted to show was shared storage, and then upgrading, how we can actually upgrade. So I don't know if there's any questions or things, because I want to move on to shared storage next. So I'll talk about, I have these 2 stacks of in here, Gluster and Convoy Gluster. Want to show how we're going to integrate that into the application.
Awesome. Yeah, fire away. And guys, if you have more questions on like load balancing, console, etcd, these type of things, We'll try to get to it at the end, because obviously it's an area that a lot of people have good questions on.
Okay, so what I'm going to do is, so we've stood up this this application which serves up music. Now I want to actually hook up music to it. I want to store some music, and so there's various different ways you can do that with the program. One of it is remote. You can just do something. It looks like it's some XML RPC-based protocol or something. Or the other thing is you can just use a directory on disk, which would be most likely like an NFS share or a CIF Samba share. What we're going to do is we want to actually have this serving content out of Gluster. So I want to have a lot of music, so I'm going to set up a big Gluster volume, put all my content in it, and then this will access the storage out of Gluster. So what I've done, I just switched environments. So everything I've been doing so far is in the default environment. So I have actually deployed Gluster and GlusterFS already and pre-populated some data. So I'm going to switch to a different environment and show deploying those. All this Gluster stuff and a lot of the storage stuff we're doing, this is being released to Suite. It's kind of experimental, but we're focusing a lot of effort on how do we actually manage persistent workloads. Everything gets exponentially more difficult. The scheduling gets more difficult, and we'll kind of show some of this stuff of what we've been working on around storage. So what I'm going to do is, so the very first step is we need to deploy GlusterFS itself. So in the, where is it? Okay, so this is the catalog that we have things that are kind of already prepackaged stuff. These are just basically, if you look in the catalog entry, it's just pretty much a Docker Compose file and a Rancher Compose file. But here we have this GlusterFS stack, and so we're going to deploy this GlusterFS, and when you do this, we create one volume automatically. But you are free to, like, once this is up and running, it's just GlusterFS. You can create some more volumes. But here we'll just go with the default of my vol. Okay. So let me just say launch. And that's starting up. This may take a minute or so to start up, quite a bit, to kind of get the system initially up. So while that's deploying, let me kind of go on to kind of the next step. And that is the Convoy Gluster. So what I just did before is I just deployed GlusterFS itself, which is just the storage system. Now Convoy Gluster is basically the integration between the two, where we basically create a Docker volume driver so that this can all plug into Docker through their volume drivers. And then additionally it has some code which integrates with Rancher, which feeds just some additional metadata so that we can do better scheduling. So if I go and I deploy Convoy Gluster, again, we need a stack name. We'll just call it Convoy Gluster. And then we need a host label of where we want to schedule this. And so what this is I'll deploy Gluster, like maybe they'll be on a set of nodes. Now, by this scheduling, the host label of where we want to schedule the Convoy Gluster is which nodes can consume the cluster. So you might want to set up like different failure boundaries or something, because an environment in Rancher is not tied to like one specific region or zone. An environment can span regions and zones, and quite often people will do that for kind of like an HA or a failover setup or something. So let's say if you're spanning regions, you probably wouldn't want to run a clustered like a clustered file system like this across regions. Like the latency is just too much. So you would probably deploy one in one region and another in another region. So we use the scheduling rules basically to allow us to do that. So here we're going to point this to the GlusterFS service. I'm going to unclick the start because I want to make sure that the Gluster came up first before I actually start this. So let's go back to the stacks here. Let's see, it's GlusterFS. It's still starting up. Running. It's almost there. It looks like we've got one more that's starting up. Networking. Okay. Let's look at this. So it's got just one more. Oh, okay. Yeah, the network agent. This is actually the first time I've used this environment. So one of the very first things we have to do is deploy our network agent, which manages all the networking. So this is what basically waiting for that to come up.
There was a question while we're waiting, just asking about Convoy and what it will support. Um, oh, you asked whether you thought we might be able to, Convoy would be supporting AWS EFS, and would that be available around the time EFS goes GA? Do you want to just kind of talk about that?
Yeah. So AWS, the EFS is basically NFS. I'm not sure if we need to do much further integration between with Amazon beyond just NFS, but we do have this Convoy NFS, which will this catalog. I'm running from like a beta catalog. I'm not sure we're going to push this out this week. I know Convoy Gluster is going out this week, but I think NFS might be like next week. But we will have support for NFS. That is kind of the most popular use case for shared storage. Like the Gluster stuff is cool, it's fun, but really a lot of enterprises, of course, are using NFS, and that's obviously why Amazon created EFS.
There was a question on NFS, actually. It was more just about Gluster and NFS, and Antonio was asking how's the Gluster's performance compared to classical NFS mounted volume. Any thoughts on that?
I can't really say. Like I haven't like I wouldn't be the one to kind of say like what the actual performance of Gluster and everything. We've mostly been focused on orchestrating. Like from our perspective of Rancher, like Gluster is just one of many storage systems, and it's the one we've kind of been using in a lot of demos lately. But from a Rancher perspective, we're mostly focused on like the orchestration and scheduling and stuff around storage. So I wouldn't say I'm exactly a Gluster expert.
I think the key with Gluster, the reason Gluster was one of the ones we chose first is we had good reviews from it from a number of customers who were using it. So we had nice, a lot of people liked it. But the other thing that we liked about Gluster was it's obviously portable in and of itself. So conceptually, this Apache stack that we're building today, everything is cloud independent, really. I mean, if you think about what we've deployed, it's the app, the network, the load balancing, the service discovery, the storage, the database. It's all being done in a way that it could run anywhere. And we do tie it into the DNS service for Route 53 in this demo, but obviously that could be anything else as well. So you get the idea that what we're building here, and our goal has always been with Rancher, is to make something as easy and awesome to use as Amazon, really, but make so it's not tied to any specific infrastructure stack. So deploy anywhere, run anywhere, port anywhere. So kind of back to the earlier question, how do I get this stuff to move? That's really one of the reasons Gluster is such an interesting use case. So is Ceph, so is other kinds of software-defined storage, and hopefully we're just now entering a golden age of this software-defined storage opportunities where more and more storage vendors are going to be making their software available for this type of, persistent storage services, as opposed to, having to buy hardware stacks to get access to cool stuff like NetApp, Snap, Mirror, and stuff. So there was a last question on this topic that came in from Joseph. He said, is the NFS support for v4 only or both 3 and 4? And I'm assuming that means NFS v4.
That is an excellent question. I believe it is. So I believe it's 3 and 4. Honestly, with the 4 stuff, you're probably going to have to configure more on the host to do the some of the security ID mapping stuff that like 4 requires. But basically, when you do NFS, let me see if I can just click on that. It's actually it's very straightforward in terms of pretty much what's the server, what's the path, and what are the mount options. The mount options are the same thing to pass to like the Linux mount. So you can put, I can't remember what it is, like ver equals 4 or 3 or whatever. So it's basically going to depend a little bit on the host.
Just before we get off this page, Darren, I mean, one of the things too that just is worth mentioning, in case people aren't clear on it, these configuration options that Darren keeps showing, these are basically using compose variables. So, now that Compose supports the concept of a variable, we're able to incorporate configuration questions into the Rancher Compose catalog section. So you can see here the examples here of Compose questions that we expose, that making them required and what needs to be in them, and then that all generates an answers file, which then ships with the Docker Compose file to bring up this application. So as you start to use your own catalog entries and deploying an Apache catalog item, you would have whatever elements are configurable that you want to make options to be changed. You can make them into these little catalog questions. Okay, there's a question on the networking, on the storage side, that said, can you say a few words on Ceph versus Gluster, and any thoughts you have on that? Do you want to touch on that, or do you want to push that off, Darren? Maybe keep us moving.
Yeah, I mean, I have a lot to say. We've had a harder time getting Ceph up and running. Gluster was definitely easier. But again, no, I don't have a lot of great insight there.
Okay, let's keep moving. Let's see if we can finish this thing up. People have to go. People got other things to do. Great questions though today.
Okay, so I want to show. So basically, we got the Gluster FS that hopefully up and running and everything's active. That looks good. So we need to just basically start up the Convoy Gluster stack. So you can see those are activating. When I go over to this infrastructure tab, we have this new button here for storage pools. And so basically what's going to happen, like this integration we have with Gluster and Convoy, is basically it defines this new storage pool. You can see that just popped up. Okay, so I can go in here and add a new volume, and it will go to this storage pool. And now the storage pool is scoped to a series of hosts, like it's only available to these hosts. So I can add more hosts. And so we do scheduling now based on storage, so like kind of like the affinity of where the storage is. So to kind of demo this working, if I go, I should be able to log into two separate hosts here. Let me make so this is not full screen. That's right. Okay, so I'm going to log into, this is the demo 01. Oops. Oh. I don't think I have the SSHP on my laptop. Oh. Okay. So I'll switch to the other environment because I have SSHP. So basically, we got Gluster up and running. I can demo this from the other environment where it's still running. So this other one where I already have, this is the environment where I've already deployed Apache. Like I already created one volume here called Media 1. But what I'll do here is let me log in. Let me log into this host. So I can kind of show you. Okay. And then I'm going to log into a second host. Okay, so when we deployed this, basically this pool here is called Convoy Gluster. That ends up being the same thing as the driver that we're going to use. So if I just go and say docker run, I'm just going to launch an Ubuntu volume here, but I'm going to say -- volume driver equals Convoy Gluster, and then I'm just going to call this demo, and I'm going to mount it to /MNT, and I'm just going to launch an Ubuntu container, which apparently has the download. Okay, that shouldn't take very long. Okay, so I've done that. I should have now. Okay, so I now have. It's supposed to be basically what's mounted at the mount is going to be the volume that I just created. Now on this other host, if I run the exact same, basically the same command, I say volume driver is Convoy Gluster. I believe I called it demo. It goes to MNT, Ubuntu. Okay. So I should be able to touch a file there, and I sure hope this works. Yes, and I see the file. Okay, so I'm sharing that between these two. Let me just refresh and show on the UI. So basically what we have now is in this Convoy storage pool, I created this volume called demo. You can see it's stored between Stupefy 4 and Gigantic Bear, which are the two containers that I created on these two hosts. Okay, so it's now using shared storage across these two hosts. So going back to my example application of Apache, if I go back to, let me make it full screen again. Log out here and go back to my application, Docker Compose. What I want to do now is I'm going to just say volume driver. Same thing I just typed on the command line. Basically, volume driver, Convoy Gluster, the name of the storage pool. And then I'm going to say volumes. It's going to be media 1. This is the one that I already created. Right. Oops. You can see I already created here, media 1. Media 1, and we're just going to mount that to media. Okay, so now I'm going to go and do an upgrade on that application, which will recreate that container, and then it should pull in media 1. So it takes a little bit to do the upgrade. Yeah, okay, so you can see media 1 is being used now by Apache 1. If I go, I never actually ever scaled up this service. Let's go to the service here, and let's scale that up so we get 2 of them. So as soon as this the second container starts, I should then see that that same volume is being shared between the 2 applications.
And if there was a, just on this, there was a question earlier from Alejandro asking if we could show scaling. This is all showing just sort of manual scaling, but if you haven't attended last month's meetup, we did a big session with Sidekicks talking about monitoring. And I think a lot of the direction that scaling is going is to enable hooks for external systems and for your own code to call out to scale up based on events like number of sessions and things like utilization of the hosts, things like that. So yeah, great questions.
Yeah. Okay. So this scaled up. So I got 2 of them. They're both mounting this volume to the same place. So if I go and I actually click on these, so these are the 2 containers. I just launch a shell. Should be able to see. Okay. Media, 2 MP3s in there. My gigantic collection of music. And then if I click on the second one here, list media, also I see the same thing. Going back to my actual web page, Apache space, I think you actually have to configure a catalog. So if I create a catalog of demo, type is local, I just want that from media, add that catalog, found 2 files, created that, and then I think you can just start linking it somehow. Yeah. Oh, you know what? There's one little gotcha I'll show you. When I was demoing or figuring out this application, and it seems to be that there's like sessions. Let me go back to, I'll show you here. There seems, I think it actually keeps like a web session. So if I go and I look at my load balancer, or we just deployed the load balancer through the UI, right? Okay, yeah. So let me go to the load balancer service here, and let's open up this. So here's the health check that is put on by default on there. But the problem I ran into with this was that the load balancer needs to actually support session stickiness to make this thing actually work. So let me just do that really quickly. Show you how you can do session affinity through the load balancer.
Hey, while you're pulling that up, there were 2 questions on these mounted volumes from Michael. Michael's first question was, how's the speed with mounted Gluster volumes in this fashion? And the second one, is it possible to limit the volume size for a mounted volume? Do you want to tackle both of those? So
again, I can't comment a lot on the speed. The speed is going to be very dependent dependent upon the infrastructure. So what's like if you put it on really fast SSDs, then it's obviously going to be faster than what the networking is. So you can get decent, performance on Amazon with their SSDs and like 10 gig networking. And then, sorry, what was the second question?
Can you limit the size of the volumes?
I believe so. Yes. When you create, that's it. So we, by default, just go and create a. Okay. So let me explain exactly how we're doing the integration. There's a Gluster volume and then there's a Docker volume. The Gluster volume basically creates like the mount, and then you create multiple Docker volumes in the Gluster volume. So you can limit the size of the Gluster volume, and that's just a Gluster FS option. Like when you're creating the volume, you can just go and create a different one. But right now, there's no way to limit the size of the Docker volume. So how much a container takes of that Gluster volume, we don't limit in any way.
Is that just a natural limitation within Docker, or is that more of a implementation decision?
No, it's just a natural limitation right now in terms of like there's not a lot in terms of limiting the amount of storage it can take. Yeah.
Great. Okay.
Okay, so going back to sorry. Okay, so this.
Before we get off that, there was like a whole bunch of follow-ups. Could you use a quota in the container for the volume if you wanted to sort of limit it in some way?
Well, the quota, I hope I get this right, is mostly around the limiting the amount of I/O. So you can say like limit how fast it's accessing disk, but not necessarily the amount of storage.
Okay.
So to limit the amount of storage, you have to, as far as I know right now, is you have to use something that's more oriented like at the file system here. I'm not totally sure. I actually have to look. I'm sure there's like the Linux quotas you can probably use.
Yeah, he was saying quota as in the standard old school quota style.
Yes. Okay. Yeah. So that like the old Linux quotas. There's trying to think because the quotas are applied at user level. It might be a little tricky to do that because then the user in container A is the same like UID that's in container B. They might get the same quota. So it might be tricky. It's a good question. I mean, I really have to look into what's the best approach for limiting the amount of storage.
Okay. Let's keep going.
Okay, so what I was going to show you is this is one little gotcha that I ran into while setting up this demo that I realized is that we actually need the session affinity. And so basically what I've done is I've just copied down this load balancer, the configuration into these files so I can just edit this. But basically you can do this load balancer config LB cookie stickiness policy, and you say cookie and then whatever name of the cookie you want. So I just named it session. So here I'll just delete the load balancer and create a new one. Shoot, I think the project was LB RM LB. That should delete the load balancer. Yeah, that's gone. And then let me just bring it back up. You can also, I guess I could have dynamically changed the configuration. That would have worked too. Instead of actually deleting it, wouldn't be the best thing to delete the load balancer introduction. Okay, so in theory, let's see, unable to connect. Oh no, it's not coming back. Let's see. Everything was going really great until this very last thing.
This is probably the best we've ever done. Usually we have way more meltdowns by 2 hours. We're an hour and 56 minutes in. If this is the first real true gotcha, I think you're getting better, Darren.
Yeah, let me see if the load balancer actually like really came up. When you look at the what host it's on. Host at IP. Oops. Ah, crap.
That won't work.
Yeah. I wonder if I had like a little DNS propagation issue there or something like that. Yeah, let's see if I can actually play something. I'm not totally sure how to use this. Play.
Hey, your data's there. There we go.
Yeah.
I don't know what happens. You're gonna hit play. Let's see if it comes through over the speakers.
No, hold on. I think you have to do the web player here, and then there's somehow it pops open like an HTML5 player. Yeah, so this is working now.
Paolo spotted your mistake. He said you had a period at the end of your domain before the port when you were trying to do it before.
Oh, okay.
You were wondering.
Let's see.
Thanks, Paolo. You just saved Darren all that fun time.
Why don't you just leave it at that? Because like, if I click on it and find it's a different problem, it's like, oh no.
Yeah, that's true. You could just. That's not a bad idea. I think I see a period though. You're right. It's right there.
Yeah, maybe a little bug there. It's going to space, and then what is it? Apache.
I think it was Apache.
Apache. Okay, yeah. All right. Okay, good. So it still works. So not bad. Okay. And the very last thing. Well, we're at 1 hour, or we're at 2 hours now.
I think it's time. We're going to start sending people home to bed.
Yeah.
What were we going to show last? The last thing we wanted to cover was an upgrade of the service.
Was upgrades, but that's a whole. I mean, that's a whole can of worms. But then that will. Yeah, I don't think we can cover that. We wouldn't do it justice in a couple minutes. So maybe we should do that as another meetup.
Do you want to just maybe touch really high level on the concept around upgrade? I mean, we kind of I feel like it was part of the selling. So
I know.
We did say we would do upgrades, so I feel like if we totally gyp people on this one, you gotta do something.
I'll do something here really quickly. So let me show you. So the basic idea of upgrading. So a while back we released the feature of doing rolling upgrades between services, and that's like so. That's a very basic functionality. Let's say I create a second service. Doesn't matter what this is. Like, so I'll call this Apache 2, and this is actually. So I'm just kind of giving you the idea here. This is obviously not going to be the real thing. So if I had one service and then a new service, I could launch this second service and do a rolling upgrade between the two services. So start scaling up the destination service while I'm scaling down the source service. We had that a while back. It's worked for some users, but the feedback has been overwhelmingly that people want in-place upgrades, which is basically the ability to upgrade something just directly itself. And so in the UI, you can just do this if you want. Like if there was a version 2 of this, which there's not, I can just go and say upgrade, and this will determine the batch size and then what's the interval. So let's say if I scaled this to 10 and I set a batch size of 2 and an interval of, a minute, then every minute it will delete, spin up 2 of the new ones and scale down 2 of the old ones. And this works with like Sidekicks too and everything. And so this all works from a command line too, and I've actually been doing it, as we've been changing things. I'll show you here, like we'll just do something really dumb here. We'll upgrade this to Nginx. So if I go and I say Rancher Compose up this service, Apache, we'll see what happens. Let me drop the log so you can see the message that just scrolled by. Apache dash. Okay, so when I say up here, you can see it says service Apache is out of sync. So by default, we don't do anything. We won't change the running service unless you explicitly say, tell us to. So if I add the -- upgrade flag, so this will do -- upgrade. So this will start doing the upgrade. And so what this is doing, let's see if I can catch it while it's still running. If I go to here, let's see. Oh, shoot, the default batch size I think is 2. And so there's 2 different strategies of if you want to stop first or start first that I did by default is it stops the old one, and then it will start deploying the new one or the ill version. So basically what it did there was it stopped the old versions and then spun up the new one. Now, if I go and I look at this service, you'll see it's in state upgraded, which means that we can now go and check out the service. Like, so if I go to my load balancer and see, like, okay, that was no good, like it just went to Nginx. So, like, we did this deployment, we rolled this out, and it's no good. We don't like that. So what we can do is, once it's in state upgraded, we have the ability to basically say finish the upgrade, which will delete the old containers. But in this situation, that was not an upgrade I liked. So we can also just say roll back. If I just do roll back, what this will do is it will now just delete the containers I just deployed and start the old ones. And we went through a lot of trouble making this rollback really rollback. It's not like what you see in a lot of systems is rollback is actually deploy the old version, which is not necessarily the same thing because you might have had some little differences in state or something like that. So we keep the old containers, they're just stopped, and then we start the old one. So let me just, okay, so this, I think, wait for PHP to warm up. This should eventually come up. So we've basically just gone back to the old container. So with a combination of basically the rolling upgrades that we had before and these new in-place upgrades, there's really a lot of different deployment scenarios that you can do. You can automate this all. You can do it from the CLI. Like, if you want, like for development, you can do this all in one big shot of like saying like upgrade, confirm upgrade automatically. And then additionally, you can do something like pull, --pull, which means it will pull the latest version of the image. So if you're using like the latest tag in development, you can do --pull and it will pull it. So there's a lot of ways we can piece this together. Yeah. So that's a quick rundown on upgrades.
Yeah, there was kind of a while you were talking, there was a bit of a mini revolt of our dear listeners who said they felt they had to know about upgrades. So I'm glad you covered it a bit, and definitely people were hoping to know if it was going to be if you could cover blue-green upgrades. But there was also Daryl had a question. Daryl O'Pry, he says, does storage get rolled back as well? Volumes? What all gets rolled back?
No. So storage. Okay. So I mean, so like one of the things that's interesting is like I did that upgrade, and we take into account like the volume, the data containers. Like there's a lot of stuff we do in terms of the scheduling to make sure that we don't like delete the data and stuff like that. But we don't, when we do an upgrade and we roll back, we're not like snapshotting data. It's still the live data. So if you're using like a data volume and you do an upgrade, and let's say your application messes up that data, and then you roll back, you're kind of in a bad state because it messed up the data. So right now we're not like doing live snapshots of data. I will say we do have features coming in the pipeline around snapshotting, but right now we're not doing anything there.
Awesome. Another question that someone had was more just like on a, if you were doing more of a blue-green upgrade, would you just not, would you just say sort of keep my current services running, start the new one, and then eventually transition? Like how would you recommend a blue-green upgrade?
Yeah, so for blue-green upgrade, is typically what you're going to do is within like, so right now we have one load balancer. You would typically create a staging load balancer. And so you would spin up your new service and have it registered under the staging load balancer and make sure, okay, everything looks good. And then as soon as you're happy with the application, then you just cut over the old load balancer to point to the new service.
Got it. Okay. I think that's enough. I think we can call it. There's loads of questions that are on here, but I want to get to a few things back in the slides for a minute. Darren, very good job today. I think you really only had a couple mistakes, so you get to keep doing this next month, like you.
All right.
And I'm going to just jump back to the slides for a minute, and then there are if you still have questions, fire them away. We will, as always, we will not leave until they're all answered. But feel free to ask your sort of personal questions as well. I see there's a bunch of questions about my implementation or my Rancher OS, or so. Feel free to fire those as well. And if you can see my screen, a couple things we just wanted to make sure you were aware of. So since our last meetup, we've had 4 releases of Rancher. By the way, for anyone who doesn't know, if you want to know, the reason our numbering is based on the month or the week of the release. So 42, 43, 44, 46. The reason we sometimes skip one is we use the week, so we'll have 47 this week. And then we'll have to figure out what to do in January. So these are some of the biggest things we've added recently. In 42, we introduced the user-provided metadata so that you could inject your own metadata, sort of like Darren was doing in some of the demos. In 43, we introduced the template catalog for the first time. Right now, as Darren said, it's just a Rancher-provided template catalog that we run and connect to. Some people have gotten into the settings and figured out already how to point it to their own GitHub. We're not showing you how to do that or documenting it, but you'll see it very nicely done in the UI in the next week or two. But it's really just pointing to a Git repository, so you could make that settings change yourself if you really wanted to. We also introduced in-service upgrades in 43 and the UI for Sidekicks. So we'd had Sidekicks support for a while in the API or in the CLI. We just hadn't put them into the UI. So 43 was kind of a big implementation. In 44, we rolled out that Route 53 DNS integration. In 46, we made a change to the DNS service to make it global. And Darren, do you want to just talk about that one? I always get it wrong when I try to explain it.
Yeah, so that one is, so basically this is to be more in line with Docker 1.9, how they've done networking. Basically, well, they had this in 1.8, but it's more prevalent in 1.9, which is when you create containers in a network, they just automatically get a DNS name. So if you run Docker Compose with the experimental networking support, every service just automatically gets a DNS name. And so basically we changed our DNS such, to do the same thing. Every service in a stack just automatically gets the DNS name. And now the only reason why you need to specifically link services in a stack is if you want to rename it, which is still a very important use case because you don't have to couple the name that you're looking up with the name of the service that's been deployed. But again, so this was just a change we did to the DNS just be more in line with the way Docker is working. Yeah.
Cool. And then I think everyone, we've mentioned it now a couple times, but keep your eyes on, if you don't know already, on our forums.rancher.com, we announce all the new releases. We obviously put them into GitHub, so if you're following GitHub, you'll see it. But just keep an eye on there, and you'll see that today or tomorrow we'll ship out 47. Will be available, and that will have the new storage capability, the new UI, and a whole bunch of other new enhancements. So we'll talk a lot about those probably in next month's meetup that we've shown you. We've given you a bit of a sneak peek today. If you haven't already, please join the Rancher beta. It's open to everyone. It gets you access to more training. It gets you access to special support email addresses. And best of all, it means you get emails from us asking for feedback and chances to tell us what you want in this product, what you hate about the product, how it could be better. A lot of the features you're seeing today are things that people who filled out Survey Monkeys and gave us feedback and put in issues into GitHub asked for 3 months ago, 4 months ago. So the enthusiasm everyone was showing today was really awesome, and all the questions really make this job a lot of fun. So I appreciate it. But join the beta. Get involved, contribute if you like. We'd love to see some more contributions to Rancher, but definitely get involved. If you want to, I would highly recommend joining the GitHub repos for Rancher and Rancher OS if you're using them. There's just a ton of content going on there all the time, tons of issues being debated, tons of plus ones and alternate approaches to concepts. And we're all in there all the time, so we kind of live in GitHub. So if you're not using it, jump in, see some of the other stuff like that we're doing. Sometimes will show up there way before it comes in the product. So get involved, and thanks. So feel free to drop off now if you don't have any questions or don't want to hear the rest of the questions that people have had. But why don't we then jump in and try to answer the last few questions from today's session. So I'm going to kind of go back to the beginning. There was a question that Michael asked about multiple IPs per host. I know with 1.9.7 it's starting to become popular for multiple networks.
Yeah, so we don't have, I guess, basically concrete plans around that about multiple IPs. I mean, so the things that we are, I'll tell you a couple things that we're looking at is the DNS integration. Right now, it registers the IP, what we call the agent IP, the IP of the agent. Right now, the DNS, like Route 53 integration, will register that IP, and so we're going to change that so you can specify a different IP. It's most likely going to be based off of host labels. And then additionally, we'll add support to binding ports to different IPs. Right now, we only give the option of basically exposing the port to all IPs. So one of the bigger questions is, I don't think we have a great answer right now, is if I'm creating multiple networks, because now in Docker 1.9, I have the ability to create multiple networks. If I create multiple networks, can I separate that traffic over like different interfaces and whatnot? And that one's like a little bit of an unanswered question. We're still looking at that. So we're adding more support for multiple IPs. I'm kind of curious on like if there's a specific feature you're looking for, because it's kind of like a case-by-case basis. We might be addressing it. Like, yeah.
Great. Okay, so there was another question that Michael had asked earlier that I was going to try to get back to, but he was asking about best practices for using private registries. So right now it sounds like he's deployed a private registry, connecting it using sort of Rancher's private registry add registry function. But I think we've heard this from other people that it seems like registries have been a bit unstable and people are not really thrilled with this. I mean, obviously, Docker Trusted Registry is out there as a solution that is enterprise grade, has support, and has a ton of security and configuration that you can use, and it works great with Rancher. So Docker Trusted Registry is a great option if you're looking for something that you use and you want more from the registry than what you get out of just the open source. It's similar in some ways to just Docker Hub, though it's still not quite the same. There is, we certainly have a lot of people who are using Quay.io, but one of the more popular uses is actually just Artifactory. If you have Artifactory already, it works pretty well as a Docker registry. It's often already sort of integrated with your systems, and you've already got it connected to your user management and stuff. So certainly would recommend that. One of the things we will be doing is adding some registry pieces to the catalog. I think we've had this request from a lot of people for almost like a managed registry within Rancher, something that's sort of fully implemented. We're still kind of figuring out exactly what something like that will look like, but it is a common request. So a little bit on registries there, Michael. Anything you want to add to that, Darren?
No, I was saying we get that request a lot. We're definitely trying to figure out what's the best approach of deploying and managing the open source or integrating with commercial offerings.
Great. Then another question came in. This was a question that Joseph had just now, and he was asking if there are ways for pulling in external API services, such as Amazon API Gateway, to be offered as a back-end service for the containers themselves. For example, on internal APIs and services that are managed on other cloud platforms. So do you want to talk about external services and sort of the idea of an external service?
Yeah, so basically, we have our DNS-based service discovery, which you just kind of get automatically for any service you've registered in Rancher, any container you've deployed in Rancher. But what you can also do is just register an external service, which is you just basically give it a list of IPs or a host name, and we'll make the DNS resolve to that. So it's just that's an easy way of bringing in. Oh, here, I can show it to you.
I just made you the presenter, make it a little easier.
Yeah, so let's see, like if I go into my stack here that we've been playing with, it's an Apache one. So you can just go and say add an external service, and so this is my API, and you can basically either point it to a list of IP addresses, so that will return like multiple A records, or you can point it to a host name, and we basically do a CNAME. So then this way you can, what we see, like a really common use case for this is, let's say, your database. For development on your laptop, it's great to just run MySQL. So you deploy MySQL and you expect that service to be available. But in production, you want to use like RDS. So it makes a lot more sense that you just go in here and you create a service called MySQL, point it to the RDS hostname, and then so basically your application stays the same from service discovery, but it changes per environment.
Great. And a question came in, and I'm not sure who asked for it because it was sort of said something about waiting for a name, but it's a great question, and it has to do with the admin section at the top. So if you go to admin, Darren, and you go into processes, if you're using Rancher and you've got some process that's hung, it's running, but it's hanging, it's not resolving for some reason or another. It's been running for a month or 2 months or a day or 2 days, and clearly it's got a timeout state. How do you resolve it? Like, what's the right way to clear it out, to destroy it, to stop that process, or kind of stop it from consuming memory and CPU and stuff as it's running in the background?
Yeah, that's kind of like I think one of the trickier things. The reason why we put this page here is to help people kind of identify what's going on in Rancher, because sometimes they'll say, hey, it's slowing down, or it seems like it's doing something, I don't know what's going on. So we added this, and it's really kind of a low-level view to what's going on in Rancher. And so what typically happens is, like, if something gets stuck, you'll see like a resource type and ID for some process, and the reason why something gets stuck is it's in a state and we can't reconcile it. So typically, let's say something is like agent reconnect would be one that was like, we had some bugs around that where it would just get stuck. You have an agent you don't know anything about, but it's just a process that's stuck there and reconnect. So what you can do is just go and like deactivate that. And what that means is you typically have to go to the API. And so the nice thing about the API is that you can just click around it in the UI, in the web browser. So in there it would say something like agent 42, and so I can just say like agents, 42. I probably don't have a 42. So let's find an agent here. So I have an agent here, and then I can just go and click on one of these things like deactivate, and then that'll actually run the process to deactivate it. So typically, when something gets stuck, you have to find what's the right resource. Like it might be stuck in some state, and you might need to deactivate it or something like that. What I would definitely say is, if you see something, try put in an issue or context on IRC or the forum. We'll try to be as responsive as possible. If not, you can start kind of fooling around. But this is kind of low-level stuff. So it might be a little tricky. Things aren't supposed to get stuck, so it's most likely an issue, and so we would appreciate like an issue being filed. So.
Yeah, and feel free to post it in the forums. I mean, our team is always in the forums.rancher.com, and if you just post your issue there, hey, I have this issue, this is what I'm seeing. Someone in the community or someone from our team will jump in and maybe give you some hints on what that could be, if it's something that's sort of a known issue that we're already, maybe fixing, or has fixed in a later version, or something that we can even just give you guidance on how to resolve yourself. Alejandro had a question, Darren. He said one issue that he experienced with public/private IPs is adding 2 hosts to the same environment, one with a public IP and one with a private IP, and running 2 containers of the same service on each host. When doing that, the containers can't talk to each other, but both hosts are part of the same private subnet. Is there anything in the works to make that work? Does that question make sense to you? You want me to repeat it?
Yes, it does. And so, so what's really common in cloud providers is that they have a public IP and a private IP. So Amazon kind of, push this model, and it's duplicating a lot of other clouds where, you have the public IP or the private IP. And so the way Rancher works is we just manage one IP. And so you kind of have to choose, do I want all the traffic to go through the public or all the traffic to go through the private? So then that causes problems if you want to register one as public and one as private, because they might not be able to talk to each other because of your security group rules. Even though they both have a private IP, because you registered the public one, we route it through public. So it's definitely an issue in Rancher. It's kind of that we don't separate those two things. I will say, like, when you register the IP, the primary use of the IP is to set up the tunneling. And so typically you're going to want to, even if you want that to be publicly accessible, you're still going to want to use the private IP so that you can get the communication. But now I would say, like, with like the Route 53 integration, we have overloaded and started using that IP for public stuff too. So I would say we're aware of the issue. We are working on it. There's a lot of work being done right now around networking because of the Docker 1.9 stuff. We're revamping a lot of the guts. We're making things faster, better, more reliable. So we are taking this into account. We might have a construct of, just basically what is the public and private IP of the server. We do see that. It's like a common enough pattern that maybe it should just be a kind of a built-in paid rancher. But again, we're working on it. There's not a specific solution right now, but we are aware of it.
Great. Last couple questions. This is a question about Docker volumes in Gluster, and Michael asked, do Docker volumes reduce in size when they're inside the Gluster volume to reclaim space when one file is deleted?
Oh, that might go a little bit long beyond my my knowledge of Gluster in terms of how it's working under the hood.
We actually have been talking to some of the Gluster team about maybe doing a meetup where we do a more in-depth full storage deployment around Gluster. So why don't we table that one and hit it at a later date. Okay, last question, and this is from Michael. He asked if it was a Rancher OS question. Is it possible to define roots in cloud-config.yaml? Does that make sense to you, Darren? Do you want to try and take that one?
Roots. I mean, are you talking the SSL certificate roots? Maybe.
It looks like, sorry, it's routes. It looks like it's routes.
Oh, routes.
R-O-U-T-E-S, routes.
Routes.
Sorry.
Oh, yeah. Sorry. I'm thinking. Actually, I'd have to look at the code. Just give me 1 second, and I will look and see if it's possible to specify route.
Awesome. Well, while you're looking, I will just say thanks to everyone who attended, especially all the people who posted pictures of themselves on Twitter. I saw lots of things, including a Docker coloring book, which I was quite impressed with, and some Rancher stickers, which was kind of cool. Someone had managed to festoon their workspace with Rancher stickers. So I wish we could send stickers out to everybody who asked all these great questions. But you can find Rancher stickers on Sticker Mule. We got them printed there, and apparently they're in the catalog. Because I keep getting little notes that people are buying Rancher stickers on Sticker. Apparently that's happening out there. I love fans. All right, you have your routes question? I think I say the word routes.
So you do not. We don't have the ability to add route. Obviously, you can just put it in a startup script in the cloud config to just add the route to but it is not like in the declarative configuration. I would say put it in an issue. That's a really simple one to add, the ability to add routes.
Yeah, he was saying he has to define a static IP for the server, and he has to manually define a route every time the machine boots. So,
harsh.
Yeah, if you don't mind, Michael, if you don't mind just putting an issue in, we'll try to get that fixed in 0.5 or 0.
Yep.
Yeah, next release. Okay, everyone, thank you all for attending today. So many people that stuck around for so long, 2.5 hours, maybe a record. And we'll put this up online very soon and send out an email. So if you want to show it to someone or share it with anyone, please do. Please spread the word about these meetups too. Invite other people to attend. We love seeing so many people. Pretty soon we're going to max out the 500 people we can allow in on a single into a single meetup. So that'll be a good problem to figure out when that happens. But thanks a lot. It was great talking to everyone today. Thank you, Darren. Great job on the demo, and everyone have a great day.